So my name's Jim Madge. I'm a senior research software engineer at the Alan Turing Institute, and I've been working on our trusted research project, Data Safe Haven, for about 4 years. So I'm going to talk a bit about our experiences, what I think we've learned, maybe dispel some myths about working with sensitive data. And so, of course, the natural place to start is, why do we want to work with sensitive data at all? And I think in very basic terms, research uses data, and research, I would hope everyone at a research software engineer conference would agree, can produce outputs which will benefit society. Now, some data just happens to be sensitive, and if we cannot use that in research, then we're going to miss out on the potential benefits of research using that data. And some very important and quite large classes of sensitive data, obviously including medical data, also administrative data, financial data, commercially sensitive data. So we want to be able to use it, we want to be able to get those outputs, but it is difficult because quite naturally and reasonably there are security, privacy concerns about the use of that data, how it's handled, and any potential consequences or harms if that data is disclosed in an unauthorized way. So trusted research environments, TREs, are a solution to this problem. They are computational environments which have technical but also policy controls in place to prevent unauthorized data exfiltration and to enable research. So a lot of the, I think, sort of common view of TREs is that they're about maximizing security, they're about locking everything down and being restrictive. But they also do need to provide an environment where researchers can work productively, because if they fail to do that, then work doesn't get done, and again, you miss out on these outputs. And a lot of what we've done in Safe Haven is trying to work to achieve a good balance of maximizing outputs, enabling researchers, while also including a reasonable, sufficient amount of security. So I'm going to talk a bit about the Data Safe Haven project, what we do, and a little bit about the history. I'm going to briefly sort of speculate on what real security is, and maybe dispel some myths about that, and then going to talk about some of the wisdom I think we've gained over the years working with sensitive data, and then refocusing back on Data Safe Haven, talking a bit about work we have done and are doing to try and get this balance right and enable researchers. So first of all, the Data Safe Haven. So the origins of the project are in 2017. So at that point in the Turing, there was a kind of data science hackathon event which was going to use sensitive data, and so to treat that data appropriately, a TRE was used. At that point, we didn't have one. The TRE that was used gave a fairly poor experience to the researchers. They found it kind of inflexible. A lot of the packages they really relied on were not present from the start, and getting packages installed, tools they needed, was a sort of back and forth negotiation and added delays. So it was kind of a negative experience. And so from that, the project came about, and our aim was to create an environment that we could use for world-class data science. And in doing this, realized that what that means is to find an appropriate balance between security and productivity inside a TRE. And then the following year, 2018, the first sort of beta version of this was used in an equivalent sort of hackathon inside the Turing. And so initially it sort of starts out very much as we've got a problem, we're trying to solve our own problem. But as time has gone on, we've become much more community-minded, and we're very much interested in solving the general problems, solving everyone's problems, and working collaboratively with others. So that's all very well and good, but the question still remains, like, what do we actually do, practically what do we do? And I think there are sort of three main aspects to that. So we have our TRE implementation, Data Safe Haven, which you can see the PyPI link there. We've recently released version 5, so you can download and use that and give us feedback. We'd be very happy. So this is an open source TRE implementation. We use infrastructure as code tools to manage the deployment of the environment. And we really think that's a good approach because it means deployments can be reproducible within sort of reasonable means, and they're quite easily configurable, so to change parameters and sort of reapply changes. The deployment itself, there's a command line app to manage the deployment, and there are very few manual steps. I think there are sort of very few left, and we're sort of working those out. So setting up a TRE is actually quite a quick process, probably less than 2 hours now. But a TRE isn't just infrastructure and it isn't just code. It wouldn't work without all the policies and processes that are required to operate it safely. And so we also work on that. And our documentation and processes, in the same way as our code, is open. Others can use that. They can contribute to it. They can adapt it as they like. And additionally, we're also quite involved in shall we say, the sort of discussion around trusted research. We produce papers about working with trusted research and our designs for TREs, which have been fairly influential for other TRE designers. So Microsoft, AWS have been influenced by that in their trusted research products. And of course, we are a TRE that operates and is used for working with sensitive data. Mostly this is internal work at the Turing, so there are the hackathon events, which I mentioned earlier, which takes place a number of times a year. Other research projects at the Turing, which involve sensitive data, but also we do have some external users. So the University of Nottingham has built their institutional TRE using Data Safe Haven, and they're also working to build on it to provide the East Midlands NHS subnational SDE, which is sort of like the NHS's TREs. Over that time, the type of data we've handled has been quite diverse. There's been medical data, financial data, commercially sensitive data, and from quite a range of data providers as well. So I think a sort of maybe a common misconception about security or how TREs should work. It's fairly natural to say, well, this data's sensitive, disclosure will be really bad, so we should do absolutely everything we can in order to maximize security, minimize the likelihood of data being lost. So that's a security maximalist approach. But there's a problem with that. So not all security improvements you make will be particularly significant. Some of them will hamper productivity, so they'll make things more restrictive, more difficult to do work. And in more extreme cases, it might actually cause more harm than good, particularly if you encourage people to try and bend the rules or subvert them. And really, I think the reality is you cannot eliminate risk. You cannot say that data will never be lost or compromised. And so every piece of work really should start with a discussion and negotiation about what an acceptable risk is, and you have to try and balance the benefit of the outputs of what we were trying to achieve with your work with the disclosure risk. So I'm going to talk a bit, so expand on that a bit and talk about some lessons I think we've learned over the years dealing with sensitive data. So yes, like quite related to what I just said, there is no single security configuration which will suit all projects. And if you try to only have one, it has to be for the most secure, it has to be the most secure, it has to be for the highest risk data projects that you will handle. And that means that any piece of work which is not that most risky work will suffer from the additional restrictions that are in place. The way we approach that in Data Safe Haven, we have a set of security tiers, which are collections of technical and policy controls. And we apply different tiers to different types of work to get that sort of suitable balance of security for that project. Vulnerability does not work quite the same in a TRE as outside. And even things which you might consider to be quite extreme, dangerous bits of code, particularly malicious code, might not be very worrying to have inside a TRE. The TRE should be robust. I think we like to talk about being secure from the inside. So in particular, network attacks probably aren't much of a concern because your TRE isn't very likely to have network connections to the outside world. And I think my personal opinion is that a TRE should really be robust to privilege escalation. So even a rootkit or something, you shouldn't really be that worried. The worst that should be able to happen is someone trashes that component of the TRE. It shouldn't make it any easier to exfiltrate data. In Data Safe Haven, the data flow on the network is restricted at an infrastructure level. So privilege escalation really doesn't make it any easier. Privilege escalation within the environment really doesn't make it any easier. And because we've got this fairly confident security stance, we think we're secure from the inside, we're not very worried about allowing people to have additional software in the environment. And there's a nice trade-off there that researchers get the packages they want, whatever they need to help them be productive. And we don't really have to delve too much into how safe do we think these packages are, or sort of trying to assess that sort of thing. Bringing data into the environment can be very helpful. Introducing new data, which might help research, particularly code. But bringing data in does elevate risk. So if you had imagine a pseudonymized data set, there will be some data that you could add to that, which would let you actually re-identify individuals in that data set. So you increase the risk, naturally, by bringing data in. However, again, if your environment really is secure, that's not too much of a concern. That sort of, even in the case of people being re-identified, that sort of degradation of security is only limited to the people who have access to the environment. And I think it's important to focus on the thing that you really want to prevent. Your real goal is to prevent unauthorized exfiltration of data. So I think in general, and I think the community is coming to this position, we should be less worried about what we let in and much more worried about what we let out. And I don't think we're quite there yet, but we're working on ways and thinking about how can we help people introduce the data that would help them be more productive and make that sort of an easier process for research, while also sort of maintaining our security stance. Planning ahead is very important. So as I've just said, the thing you really don't want is to let out sensitive data. But at the end of your bit of work, your bit of research, you're going to have some outputs, and you're going to want to remove them from the environment and put them in the public. So that means everything that comes out has to be checked. That gets particularly difficult in the world of AI and machine learning. If you've got a model, that's going to be incredibly difficult to inspect that and really be confident in saying, I don't think there's any way you can get this model to dump out some sensitive data. And if you cannot come to the point where you're happy to release the results, you've really wasted a lot of time and effort, because you've done all of the work, you've got the results, but now you're not able to use them because you're not confident they've got to stay inside the TRE. So that's really bad, and I think planning ahead is really important. The way we handle this, we have a concept of work packages, and that's what we classify into our security tiers. And a work package is a more holistic view of a project. It's not just what's the input data set, how sensitive do we think that is. It's the combination of all the data that will be brought together, it's the work that will be done, and it's the intended outputs, and that really helps head off that sort of problem where you get so far through and then realize all of a sudden we've got something which we don't quite understand and we don't think we can release. Perhaps, I'm not sure if this is controversial, but certifications are not security. So at least at the moment, there is no certification that says this is or this is not a trusted research environment. And I mean, certifications are a fantastic sign that you take security seriously and perhaps more broadly sort of IT security, but it's not the same as what is a trusted research environment. And so having a list of certifications doesn't mean that data egress isn't trivial, or that this system has been designed to not allow data exfiltration. And I think similarly to what I said earlier, focusing too much on that might end up distracting from what's really important. I think a number of times we've sort of been approached by collaborators saying, we want you to have this certification, and well, maybe we do or maybe we don't have it. But whether we do or not, that's not actually what they should be concerned about. It's not really a great indicator of what the risk is of them handing their data over to us. What we have done, we collaborated on the SUCH project, so that stands for Standardized Architecture for Trusted Research Environments. So that is the first, I believe, certainly the first that I know of, specification for what a trusted research environment is, what are the sort of essential qualities of a TRE. So we invested a lot in the development of that and have certified ourselves against that and continuing to support that project. We also pursued the NHS DSPT self-certification because that's necessary for handling NHS data. So we've been fairly pragmatic in what we approach, but we try and focus in on the things which are sort of really essential to get work done, or the things which really set out what a TRE is, rather than sort of more general IT best practice things. Technical controls, yes. So people, I feel, often have a desire, maybe a belief, that everything can be fixed with technical controls. There's some sort of tech, some software you can run that will fix everything and make it impossible for data to be leaked. And it's not true, and I really think that is more of a people problem. I don't think there is any technical control that can really guarantee you can't leak data. If someone has a phone or a camera, they can take pictures of the screen, and okay, it's not a particularly efficient way to leak data, but it could be done. And you really need a combination of technical, perhaps physical, and policy controls in order to stop bad things happening. So I think you really need to remember that there are times when it's appropriate. So either when a technical solution isn't feasible or where it's impractical, that it's completely appropriate then to rely on perhaps physical controls, but also policy controls, and to distribute your trust. So don't just trust in the tech, but make sure you have trust in your people and your policies. So yes, that's what we do. We have a combination of technical and policy controls, and in our documentation policies, we've got quite a lot of focus on user training for different user groups so that they understand what they should be doing, what their responsibilities are, and what the risks are. When working with data providers, often you might reach conflict or disagreements, and very often a quick conversation is really all you need to sort that out. I find data owners can often have quite a skewed impression of risk. in my experience, they tend to really over-evaluate risk and will often sort of drive for more strict controls than necessary. So we've got quite a lot of experience of talking to people and explaining the trade-off they're making, that yes, we can make the controls more strict, but you will be less productive, you will get less out of this work. And again, focus on why are you trying to do this work, what's the benefit you want, and what the cost of that against any risks are. So now that I sort of shared what I think the lessons we've learned are, I talk a bit about how we try and address those and what we do practically to try and strike this good balance between security and productivity. So the workspace in Data Safe Haven, we like to say, is batteries included. So it comes with, this is just a selection, but it comes with a lot of tools which researchers will want or expect to be there. So lots of programming languages, IDEs and development tools, document processing tools, creation tools for producing outputs and reports, and shared tools for collaborative note-taking and development and so on. And I think that sort of leads the question, well, okay, very well, you've sort of got the programming languages, but what about all the packages, the repositories and things? And I think we've come to quite a nice solution, particularly for our users for this, where we have a proxy to CRAN and PyPI, so the largest, I believe, Python and R package repositories. So this is configurable to either allow researchers to install any package from those repositories or install packages which have been named on an allow list. And this works such that they can quite seamlessly using pip or install.packages, so exactly as they would expect outside the TRE, to get those packages, but without the ability to use those same routes to, say, publish a package containing sensitive data. Yes, and if you wish, you can restrict which packages those are. And that has been sort of spun out into an independent project. So if anyone wants to use that in or outside of the TRE, they're very welcome to. And a bit of work that we're moving on to, which I think is really picking up a lot of momentum in the TRE community, is the idea, so I like to call it develop outside, run inside, that you should support people building the code outside of the TRE and then just bring it in to run against the data, the real sensitive data. The reason you'd want to do that is you're promoting best practice. You're saying to people, yes, you should publish this code openly, you should have CI and tests and version control and so on. And you don't get this problem of, we developed a bunch of code inside the TRE, and now at the end of the project, we've got to try and figure out, in however many thousands of lines of code, is there any sensitive data? Is there any reason we can't bring this out? And the way we're looking at doing this, so work in progress, but the way we're looking at doing this is having an internal Gitty instance inside the TRE, which through function apps, we can interact with the API and create read-only mirrors of any public Git repository. So that could be GitHub, GitLab, so on. Yes, and so that way the researchers will be able to have access to whatever repositories they'd like, so focusing in on getting software in, but again, are not able to push to those repositories to sort of trivially egress data. So yes, thanks very much for listening. I need to thank the current development team, all of whom are at RSECon, so if you want to chat about this, yes, and that hasn't loaded. Oh, that's unfortunate. So that's supposed to be all of our collaborators. Try again. Yay, there we go. Yeah, so thanks to all of our collaborators, anyone that's worked on the project in the past in any capacity. I think it's really important to acknowledge them. And thanks to Scrubbier and the Turing Way, who we work with to make the nice illustrations that you've seen. So hopefully you appreciated that, and a few less bullet points to be staring at. If any of this has been interesting to you, or you're thinking about trusted research environments, or you use or work with them, please get in touch. We would love to collaborate and talk to you. So like I said, the product's available on PyPI. You can get that and use that, and open issues. All of our documentation is also open. So again, use that, adapt that, give us feedback. Yeah, we're on GitHub if you'd like to contribute, and also a few sort of broader places to direct you to. The uktre.org, so the UK TRE community is a really active growing community. People interested in trusted research, quite a diverse group. So that's really great to join, very welcoming. And the Satchel specification is online to read if anyone is interested in learning a bit more about what TREs are, or has something that maybe they want to run a certification against themselves. So thanks very much.
Yeah, thank you. So see if we can get the questions up for this.
Yeah, where's the HDMI port?
So the code you got on PyPI, if I take that and run it, what does it do? Create VMs that have got a network that can't speak outside, or what, at a high level, what will that do for me?
Yeah, it will do a few things. So the bulk of it is Pulumi. I don't know if you know it. So it's infrastructure as code library, system package, framework. Yeah. So the bulk of it is deploying resources to Azure, which are, yes, configured in the right way. Yeah. But it will also hook into a few Azure APIs and things to help set up it's not called Active Directory anymore, it's called Entra ID for sort of holding your users and things. Yeah. So at this point, we've automated the huge majority of it. There are not many places where you have to sort of stop and type something or click something after you've written your configuration.
Yeah. Oh, nice. Okay, so we've got a question from Matt Jackery. Are you in here? He's not at the back. Okay, he's saying, how much of the security of TREs is hardening against bad actors or external threats versus researchers making mistakes?
Yeah, I think that's a really good question. It's definitely both. I don't think that's not exactly my area of expertise, but my intuition would be mistakes, yes, or innocent mistakes is much more likely than bad actors. I think that's also probably more realistically what a likely threat is. So you might get attacked externally, a sort of targeted attack. But at least from my experience, a lot of what I've seen is, I think like I spoke about a bit, people feel the rules are too strict, and so they think, how can I circumvent this? Maybe they don't use the secure infrastructure you provided at all. Maybe they take a picture on their phone. Yeah, so I definitely think you definitely need to think about both. Yeah. And maybe the focus is very much on this sort of shadowy, cartoonish sort of hackers and what they're doing. But realistically, I think the risk is probably more internal. I imagine social engineering is a much bigger risk than sort of tech risks.
Okay. Yeah, that's interesting. And another one from Matt about the work package thing. Do you customize the allowed shape of the output data for each project? I'm
going to have to sort of try and guess I know what that means. But we're sort of fairly permissive in that's certainly how Data Safe Haven works. There's some storage where you can drop inputs to, and then again there will be a storage area where you can remove outputs from. So exactly what those outputs are, anything we can put in object storage. Okay. So yeah, potentially it could be anything, but I think that's going to be part of the work package classification process. So I brought the example earlier of models. If someone wants to create a model and release that sounds very difficult. I wouldn't say we're confident that we know how to review that, and I think that would be part of the that process of reviewing that. Are you confident that you can remove this, yeah, and it won't disclose any sensitive information? Yeah. So I think I think broadly, yes, we're quite flexible with what potentially could happen, but it's all about that negotiation of how confident are you that this is okay to bring out and sort of release into the wild?
Yeah. And so compared to someone bringing out a CSV file that you can just look through and check to some model where it's buried inside, you would need to decide that up front, what
your and I think that there's a lot of work on sort of automated tools to check for outputs that might disclose or which are dodgy, and I think, yes, that's much easier if you've got some sort of known formats which you can assess in a sort of a good, robust statistical way, or if you can search through plain text. But then certain types of outputs, that's significantly more difficult. And imagine if you had images, I don't know, do you get someone to look at all of the images, or could there be something sort of encoded in the image which you could get out, but which isn't visible when you look at it? It's a difficult problem.
Yeah, well, that's interesting. Okay, we've got time for one more. I think this is Inga Ulusai. Are you here, Inga? There she's up there. So she's wondering, how do you model bad actors?
So for our releases, we conduct external penetration tests. So part of that is sort of covering the external attack surface, but also internally, and so we will instruct them to test things like, from the outside, can they break in without valid credentials? With valid credentials, when they're on the inside, can they somehow remove data which they're not supposed to? So really that's sort of our approach. I mean, we'll test things internally, but then when we come to make a release, we sort of contract that out externally and invite people to try and break it.
Yeah, okay. Good, okay. Thanks very much, Jim. That's good. Another round of applause for Jim now.
Thank you.